You should have done your prism like that. You've marked on the normal, you've shone a light in, you've measured the angle of incident, you've measured the angle of refraction, and you've recorded it in a results table, I and R, and you've done 5 repeats and then found an average, hopefully. So you've got, like, let's say 10 degrees as your angle of incidence, your average has ended up being, let's say, 7 degrees. You can then make a table of I against R, the average, and then, if you wanted to, for each individual one, you could calculate refractive index. You could use the formula, refractive index is sine I over sine R. And for each one, you could find the refractive index. In theory, they would all be the same. In reality, they'll be slightly different, but you could then average them and get an outcome. That's one way of doing it. What you're meant to do to get rid of all of your anomalies and balance it all out is you should take your I and R results, process them, sorry, this pen is no good, processes them into a sine I and sine R table with whatever sine 10 is written, write them down, and then plot a graph of sine I up the top, sine R along the bottom, and then you will get a straight line of best fit, hopefully. Remember that when we do a graph in Excel, we do the XY scatter and then we add a trend line, get it to show the formula, get it to also show the R squared, because that tells you how reliable your results are. Remember that an R squared of 1 means that there's an absolute perfect correlation. An R squared of 0 is there's absolutely no correlation. And then so if you've got an R squared of like 0.9 or above, that's good, that's a strong correlation. Anyway, you plot your graph, sine I up side, sine R, then your gradient is rise over run. The rise is sine I, the run is sine R, so your gradient is going to be the refractive index. This pen is useless. The gradient is going to be the refractive index. So from your graph, you will be able to tell me the refractive index of your Perspex block. You can compare that to what happens if you Google refractive index of Perspex. You might find a quoted value on the internet. You can then compare yours to, and if they're close, then great. If they're miles away, then why? Equally, in part of your evaluation, if your R squared is 1, amazing. If your R squared is 0, not so great, so something to comment on. Yeah? That is our processing.